Hi, this is Professor Fernandez. We are working here on class notes A in lesson 6. So in this class notes, I'm going to prove this theorem. Right, so that's what I say down here. So let's talk about what the theorem is about. So in this lesson, we are considering non-homogeneous solids. So those are solids which have a non-zero right-hand side when written in standard form. And what does this theorem say? So it says, if y1 and y2 are solutions to the non-homogeneous solid, that's the if, then their difference solves the homogeneous version, this one. So the homogeneous version is literally the same ODE except with the right-hand side being 0. So what I'm going to do to prove this is first I'm going to write down this condition. So I'm going to say suppose y1 and y2 solve equation 6.2. What does that mean? That means that y1 double prime plus p of t y1 prime plus q of t y1 equals g of t. And the same thing for y2. y2 double prime plus p of t y2 prime plus q of t y2 equals g of t. Great. And then I'm going to start now on the second part of the proof, because what I'm asked to show deals with the quantity y1 minus y2. So one thing I'm going to do here is go back and look at the quantity y1 minus y2, and I'm just going to evaluate, I'm asked to show that it solves this homogeneous version of the ODE. So I'm going to evaluate the left-hand side of that ODE when I substitute in the function y1 minus y2. Okay. And what do I get here? So this equals, I'm going to collect all of the y1 related things together. And then there's a minus here because every term has a minus sign. Collect all of the y2 related things together. So there they are, q of t, y2. And then to finish off, I'm going to go back and use these two relationships that I have assumed. All right, so if I use that here, and then I can finally finish the proof by saying, okay, so this equals 0 because of the first assumption. And this equals 0 because of the second assumption. So my final calculation gives me the sum of two zeros is 0. So what have I shown? If I go back, I have shown that this equals 0. What does that mean? That means that exactly what I wanted to show up here. That means that the difference of y1 minus, y1 and y2 solves the homogeneous version, in other words, where there's a 0 on the right-hand side of the ODE.